YUMIN Primary School.
My name is GUO CHENGXI, 8th of primary, total from YUMIN Primary School.
This lesson is Calculus, Chapter 5, Indefinite Integration. For this time, we will prove that integral dx over 1 plus x squared is equal to
Inverse tangent x plus c, and we need to use 4 methods.
First, for the integrand. Can we find the domain?
Yes, the domain is from negative infinity to positive infinity.
So the first method is
trigonometric substitution.
This method, you will use it.
Yes.
Firstly, we'll let so you want to let x be tangent x. Okay.
Find the graph for it and
So for this, theta will be inverse tangent x. Then, next is the dx. And also, theta can also be written as,
or you mean inverse?
this arc tangent x. And the range for theta. Please space it out. So theta is this range because that here can stretch down to negative infinity, and this can go up until
Positive infinity.
yes. And for this,
this be other numbers like fraction, decimal,
the coefficient, it can be other numbers,
but
it can make it more complicated. Or even sometimes you can't even solve it. And for this, it is 1 to 1, which means the theta, 1 theta is for 1 of the x.
Write down the identity, because this denominator will equals the secant square theta.
So that will be the,
Since we solved it, so we need to, and don't forget your right angle triangle. Okay, so can we use cotangent?
Okay, so let me tell you first. Here the theta you can use inverse sine, inverse cosine, inverse tangent, inverse cotangent, inverse secant, and inverse cosecant.
Yes.
There are actually 6 ways of writing it, but because we will need to prove the inverse tangent, so that is why here we'll use the inverse tangent.
But can we use cotangent?
Wait, what about the so is the integral dx over 1 plus x squared is equal to inverse tangent x plus c. And here this is, it's shown. Okay, so just now I heard you asking about the cotangent. Okay, yes, you can. Would you like to try?
Okay, and draw out the graph.
Okay. So this is the range, right?
Wait, and here didn't touch, okay?
Yes. Okay, so this is also 1 to 1. 1 theta to 1 x. You mean cosecant? And remember about your negative.
Yes, is another identity.
Here we also have 6 ways of writing the theta.
You still need to change this to a tangent, so we'll use another identity.
You mean inverse tangent?
Yes. As here, fx have 1 over x and negative, so can cancel.
C prime.
Is a prime because there's an extra
Half pi.
yes.
So like this also proves that this is actually also a so inverse tangent
Yes.
Okay, so both of these shown, right?
Yes.
So take a look at these two substitutions, okay? Okay, so this is the first method. Next. Method 2. Partial fraction, okay?
Okay.
And here we need to use the complex.
Complex number.
Okay, so we'll erase these. So for this partial fraction complex numbers, first for this, denominator we'll need to factorize. So when we factorize, here we need to have am I right like this?
Yes.
Okay, so right now we'll need to separate them, the partial fraction, right?
Yes.
So this will minus this. Is it okay?
Yes.
So that means you have the 2i. Am I right?
Yep.
But do you know why we need to have this outside?
Because we'll need to make it still the same.
Okay, because that when we common denominator, here go up, here go. Actually the times, right?
Yes.
So we have the extra 2i. But because that we need to make the question the same, so we'll need to divide that, right?
Yep.
So right now we can integrate, and when a logarithm minus a logarithm, what is it actually?
A logarithm minus logarithm is actually a divide.
So can it be like this?
Yep.
Okay, so you have this logarithm, right? But remember, because that the fraction, this denominator, we don't want the I, right?
Yes.
So we'll need to denominator rationalization, right?
Yep.
So for this denominator, we can think this x will be a plus the I will be a b. So a plus b, can we times the a minus b?
Yep.
So which becomes a So right now over here we have this square, right?
Right.
And so can we have a square root and then a square? But because therefore this, if you have a square here, you cannot separate the real part from the imaginary part, right?
Right.
We want to separate them, so we need to take out that square, right?
Yep.
So it will become like this, correct?
Correct.
And right now over here, can we separate these two?
Yes.
right now for this, what do you think the triangle will be like?
The triangle.
Can you draw it out?
Okay.
So let me tell you that this is the real part. This is the imaginary part. Okay, so the real part is along the x-axis, right? Yes. Wait, this is a 1. Yes, and that is the y-axis. So here you use the Pythagoras theorem. And it's because of these two, we had the Pythagoras theorem to find the hypo, right?
Yes.
Quickly. So right now over here, this is the x over square root. X squared plus 1. X over this, right?
Yep.
Which is actually a cosine theta, right? Am I right?
Right.
So here this I, and after the I is actually a 1 over, right? So it's the 1 over this thing. Am I right?
Yes.
Which is the,
Then the sine.
yes.
This x over this thing, which make a cosine.
Okay, so right now for this inside the lawn, what is this? Is it the Euler's formula, which is
Yes.
e to the power of negative I theta, which is the cosine theta minus I sine theta. So it will be like this. And remember, the logarithm and the exponential, here they're actually inverse operations. So here right now, the negative I theta, because I hear the logarithm, so you can put it on the outside. Okay?
Yes.
So when you put it on the outside, the I and the I cancel, right?
Yes.
Well, there's a E. And remember, ln E is actually a 1. Right?
Yes.
So right now over here, we have this negative theta. Theta, how many ways can we write it?
We can write it
6 ways, right?
ways.
Which is the inverse sine, inverse
Inverse
cosine.
cosine, inverse tangent, inverse cotangent, inverse secant, inverse cosecant.
Yes, correct. So which way would you want to use?
Cotangent.
Well, you can use
You use the tangent.
the inverse tangent.
Yes.
Okay, so usually you'll use that.
Negative.
So inverse tangent, which is the opposite over adjacent, right?
Yes.
Is the 1 over x. So right now we'll use a identity. So we can use a tangent x, right? Okay, yes, the inverse. So this negative half pi is actually a constant, which you can put it in the constant. Okay, yes, very good. And here, negative, negative.
Positive.
Okay. Like this. Is it okay?
Yes.
So we found this. Am I right?
Yeah. So shown.
So, integral dx over 1 plus x squared is equal to like this, right?
Yes.
So here it is proven, okay?
Yes.
So this is for the second method. Next is the third method.
The third method is the definition of differentiation.
Yes. Okay, so we'll erase all these. Okay, so the third method is a definition of differentiation. First, differentiation.
Can we read?
Let me test you. What is the inverse operation of plus,
Minus,
times,
divide,
logarithm,
exponential,
trigonometry,
inverse trigonometry,
differentiation?
integration.
Yes. Very good. So differentiation is the inverse operation of integration. Since we already know that these two are equal, so to prove that they are equal, this is integration. Can we differentiate to find whether from this function we'll get this integrand? Okay?
Okay.
First, let's recall some things.
And don't forget your domain.
Okay, so first for this recall, first thing, limit x approaches to 0. What is sine x over x?
That's the special limit, which is 1.
Yes. What if y is sine x? So limit y approaches to 0, and here y over inverse sine y, which is a
It's still a 1.
still a 1, yes. Okay, so right now, okay, you want to try tangent. Are you up for the challenge?
Yep.
Okay, so tell me, how should I find it? Your limit? Erase it, please. Okay, so you can just tell me and I'll write it.
So it will be a sine x over x
Is it like this?
times 1 over a
Cosine x.
x.
Because that tangent is the sine over cosine, right?
Yes, and it's still a 1.
Here's a 1, here's also a 1, right?
Yes, and it's a 0.
How about this? What if y is tangent x? How about that?
Yeah.
So limit y approaches to 0. Here is y over
Inverse tangent y.
So what happens
Still
here?
1.
Good, still a 1. Okay, so right now for these, can I just write limit x approaches to 0, and then here is the inverse tangent x over x. What would this be? Do you have any ideas what would it be?
It will still be a 1.
Good, still a 1. Do you know why?
Because,
Well, it's just this reciprocal, right?
yes,
And the letter, it doesn't matter, right?
yes.
Letter doesn't matter. So the second thing that we're going to recall, we can have a tangent and then here an angle minus an angle, okay?
Yes.
So for this, the tangent angle minus an angle, this tangent, what happens?
It will be a sine x minus y over cosine x minus y. And remember the circle kosa, kokosasa.
So this sine is the,
Sine is circle kosa,
cosine is the,
kokosasa.
yes, very good,
Sa is sine, ko is cosine.
yes. So for this, minus over here, minus. Like this,
Yes.
then here over. What can this over?
This can,
Okay, so cosine is a kokosasa.
yes, so cosine, cosine, sine, sine. At first, this is sine, cosine, cosine, sine.
What's missing?
So actually, this should be a plus.
Yes.
So then it sine, cosine minus cosine, sine. Cosine, cosine plus sine, sine.
So right now, numerator, denominator. Can we both divide by something?
Yes.
What do you want to divide? Okay. Yes. Good. Okay, so you want to divide by that. Okay. So right now over here, you already have the cosine y. So you're missing the cosine x, right?
Yep.
Sine x over cosine x,
Tangent.
x, right?
Yep.
Then here can minus. So this will actually be a tangent y, right?
Yes.
Then you will over, here's a, here, this part.
1.
Yes?
So
Plus.
you need to plus tangent x, tangent y.
Yes, correct. So, like this. What about, can I use alpha minus beta?
Yes.
Okay, so alpha can replace the x and beta replace the y, okay?
Yes.
So what would this be? Do you have any ideas?
Inverse tangent, tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta.
Yes. So it will be like this, right?
Right.
Okay. So first, can we erase the first part? And we can
Yes.
start using this, okay?
Yes.
So right now, we will need to use the definition of differentiation, right?
Right.
We can let y be something?
Fx, which is tangent x.
Like this, is okay?
Yeah.
Okay, so right now, dy, dx, this will be,
This will be limit delta x approaches to 0, delta y, delta x.
but do you know what is this? This is the definition of differentiation.
Yes.
So right now, for this can be that right?
Right.
So it's like this, right?
Right.
Then for the f can become the inverse tangent, right?
Right.
So right now for this, like this, is it correct?
Yes.
So just like this, am I right?
Right.
Then after that, inverse tangent, we're finding the, is it the side or is it the angle?
We're finding the
Angle, right?
yes.
So what do you think? The inverse tangent x plus delta x, what do you think is it like?
It should be like this.
The alpha, right?
Yes.
And the inverse tangent x? Inverse tangent x will be the?
Beta.
Yes, the beta. So for this, limit delta x approaches to 0. So like this, we actually just sub in, right?
Yeah.
Like this, is that right?
Right.
So right now, this tangent and inverse tangent, what happens? Remember, they are inverse.
Operation.
Yes. So,
They cancel each other.
okay, yes, they can cancel each other.
For example,
Okay. So basically, this is from this side. You find the inverse tangent is that you find the angle, right?
yes,
Tangent, you find the
side.
yes. So, can you give some examples?
Okay, for example, 3 times 5 divided by 5, it will still be a 3. 11 minus 2 plus 2, it will equals to 11.
Okay, so for this,
Actually, we don't need the inverse tangent because it's equivalent.
okay, let me show you. For this, for example, this limit.
I cannot say.
Okay, yes, it's correct. So let me just show you for this.
An example.
Yep. So this is actually limit x approaches to 0, x over x. So this is the 1, right? Am I right?
Yes, as it's equivalent.
Yes, correct. It's the equivalent, right? So that means this inverse tangent we can just throw it away. Okay?
Yes. We can just forget about it.
So afterwards, here, do you know what is this part?
This
So here, this denominator is still okay, right? So okay, erase this. So right now for this here over delta x. So what can you simplify?
Delta x.
Yes. These two simplify, right?
Yes.
Like this. Is that right?
Yes.
So for this, all these.
Now we can start. At first it's
At first, all these are indeterminable forms, right?
yes, which is 0 over 0.
Okay, and now we convert it into determinable form, right?
Yes.
So right now we can start. So here will become a.
There.
This is a 0, right?
Yes.
So for this 0, so that means it's an x times x. Am I
X
right?
squared. So we get the same answer.
Like this, right?
As shown.
So integral, this is the dx over 1 plus x squared. This is equal to inverse tangent x plus c. So here it is shown, okay?
Yes.
Okay, so this is the third method. Next, which is the last but not least, method number 4.
Also known as the shortest one.
Okay? So this fourth method, this name is actually very long. Okay, so this is the differentiation of composite function. Okay, the differentiation of composite function. So this will be the last method. Okay, so because that, so here we can have a tangent and a inverse tangent, okay?
Yes.
So this is a x, right?
Yes.
So here, so both sides differentiate, right? Yes. So this inverse tangent, we can just, okay, because they're here, it's a composite function, so we'll need to use the chain rule. So okay, you just leave it alone. Okay, so, yeah, so that's a 1. So right now for this secant is a 1 over?
1 over cosine.
Yes. So you can move it to the other side, okay? So continue over here. So you write this first. You write this first. Erase it. So this will be, remember, this is a 1 over cosine. When it goes to the other side, it is a cosine. So here will be the cosine square. Here's the inverse tangent x. So right now over here, we can let, right?
Okay.
Okay?
Yes.
So right now over here, this tangent y will be the x. Which x? We can write it as x over 1. Okay?
Can.
So for this triangle, this right angle triangle, here this angle will be the y. And right now over here, the tangent is the opposite over adjacent. Right? So here it will be like this. Correct?
Yes.
So afterwards for this, here's the cosine square y. Am I right?
Right.
So cosine y, for this angle y, the adjacent over hypo, which is this 1 over square root x squared plus 1. This thing square, right?
Right.
So do you know what's the answer?
So the answer will be.
So this square, right? Quickly. Okay, so there you get your answer, right? So for this integral dx over 1 plus x squared is equal to inverse tangent x plus c. Okay, so n, the bracket proven or shown. Okay, so right now we have finished all the 4 methods, right?
Yes.
So I clear off all of these.
Yep.
So you'll see, if I'm proving, we can also have many methods, right?
Yes.
Some might be quite complicated, some might be quite easy, right?
Yes.
So there are different types of methods.
Yes, and sometimes even inside method there are more methods.
Okay, yes, correct. So these methods vary. Okay?
Yes.
So are you clear of all of these, and can we stop here?
Okay, and what you want to say?
Okay, so if you like our videos, don't forget to subscribe to our channel. Okay?